Welcome. In this video, we're going to find the level curves of this function of two variables for the given values of c. We're going to create a contour map for this function manually as well. Okay, so let's begin. And before I begin, I'm going to remind everyone that in order to find the level curves, we want to set g of x comma y equal to each value of c. And c in this case, since we want all integer values on this interval with the endpoints included, we have -2, -1, 0, 1, and 2. Okay, so if g of xy equals c, then of course I can set c equals to y minus x squared plus 4. So x squared minus 4 equals y minus c. Okay, so now let's create a table. Here's c, and then the value of x squared minus 4 equals y minus c. And finally, a description. Actually, I'm going to change one thing real quick. I'm going to leave the c on this side as a plus c. And you'll see why when we get there. The last video I made, which hopefully you already watched, every level curve was a circle, and it made sense to have the c on the other side of the equation. But anyways, that is not important. All right, so now I'm going to list out my c's. -2, -1, 0, 1, 2. Please take a moment and create a similar table. Pause your video if need be. So when c equals -2, we end up with x squared minus 6 equals y. When c equals -1, we have x squared minus 5 equals y. When c equals 0, we have x squared minus 4 equals y. When c equals 1, we have x squared minus 3 equals y. And finally, when c equals 2, we have x squared minus 2 equals y. All of these are parabolas that open up towards the positive y-axis. And the only difference is the roots. So I'll do the roots in blue, just so we know these are the roots, that is the x-intercepts. So this one has roots at plus or minus square root 6. That means it intersects the x-axis at plus or minus root 6. This one is similarly at plus or minus root 5. And I wrote that badly, excuse me. Now, this one I'll go over a little more just in case you're not seeing this. The idea is to find the x-intercepts. You set this equal to 0. This becomes x plus 2, x minus 2. These are all differences of squares. So clearly this one has roots at plus or minus 2. Since 6, 5, 3, and 2, these ones are not perfect squares. All of these are going to have a radical and factor as x plus the root of something times x minus the root of something. So in case you didn't see it, that is how I'm doing this. If you still don't see it, please pause your video and work out all the roots independently. Otherwise, continue watching this video. Now, in order to help us with graphing, I will write down the approximations for all of these. So this one is about plus or minus 2.45. This one is about plus or minus 2.24. This is approximately plus or minus 1.73. This one is approximately, oh, excuse me, I skipped one. Here we are. I skipped a whole line. There we go. Root 3 is approximately 1.73, not 2. What I wrote previously was absurd. Okay. And this is about plus or minus 1.41. Now please make an axis. There we are. Like I am. And then get your ruler out. And I'll start with the horizontal axes. And I'm going to label these by a quarter unit. So this will be a quarter, a half. Actually, never mind. I should do half a unit. This will be a half. This will be 1. And this will be 2 here. And same here. So as you notice, I'm just making these tiny little, barely visible dots right now. And then I'll hide my ruler. Those of you working on paper, use a ruler, some kind of straight edge. If you're working digitally, use a digital ruler. If your app doesn't have one, then place a real ruler on top of your tablet. Carefully so you don't scratch your screen. Here we go. This is actually a better view like this. So now let me get my ruler. That's because I want the y-intercept to show up on all of these really well. So here is my ruler. And I want to make sure I go all the way to 6. So I'm going to need some more y-axis, but that's okay. Let's draw in the dots at every half unit. Okay, hopefully you created a graph that looks like this. If you have not, please pause your video and do so now. And careful with your labeling. I mislabeled mine, so let me fix that. There. Now let's go ahead and graph these. This first level curve has a y-intercept of -6, so that would be here, and intersects the x-axis at just below 2.5, plus or minus. So I'm going to go a little to the right of 2.5 here, a little to the left of 2.5 here, and sketch in a parabola. All right, there's the first one. This is our y equals x squared minus 6. So pause your video and take a moment and sketch the last remaining 4 parabolas. All right, so you should have a graph of level curves that look like mine, this contour map. These gaps aren't necessary. I just didn't want to hide the values, but the lines should be going through these, but it makes it easier to see the values. Same here and here. Okay, hopefully you found this video useful to your learning. If you're a student in my course, I expect to see your work to look just like this, including the table and this work up here and the contour map on your exams and lab assignments in order to be eligible for credit. Otherwise, you will get an insufficient justification and a 0 on that problem. That said, please keep calm and math on.